All right. Anna and Taylor are on the lacrosse team and practicing their passes. The vertical height A of X is Anna's pass X feet from where it was thrown and is modeled in the table. The vertical height of Taylor's pass is X feet from where it is thrown and is modeled by the equation of T of X. Complete the statements by comparing their passes. So what I'm going to do is I am going to put in the calculator the second equation right here and get the table of values. It's just easier to use a calculator because I could plug in like 0 and 10 and 20 and do the math, but in a calculator I could just do it faster. And so on the SAT, it's really helpful to like just plug some things into the calculator. So, anyways, that's what I'm doing. Minus 50x. So I enter it in exactly how I see it. Then I'm going to go and look at the table of values. Now, the cool thing is I could go into the table set menu and I can change this increment to 10, which is kind of cool. So I'm going to change this increment to 10, but I want it to start at 0. So now I'm going to make a table that looks just like the table that's on the thing. Okay? Huh? What do you think about that? Pretty fancy, huh? So what I'm going to do is I'm going to copy and paste that into our little notes here. And then we're going to compare the values. So these are the values of T of X, okay? And we're going to have to do some sort of comparison. T of X. It says the difference in the maximum height. So it looks like the maximum height is about 30, but now I need to be careful. It could fall between 25 and 30. So what I really should do is look at the graph. So I'm going to look at the graph. And let me just graph this. Oh, you know what? I gotta adjust the zoom on the window. So when I go into the window, I'm gonna go from 0 to 60. And then in the Y value, it looks like I need to go from 0 to 45. Now let's graph it. And we're counting by tens. So see, when I look at the graph, there's probably like a 10 and 20, and then we know that there's a 30 and a 30, but I'm guessing that there's a value in the middle here. So I'm going to let the calculator tell me what the maximum value is, which is the maximum height. So this works on the calculator. The left bound means I go a little bit to the left of where I think the vertex is. Then I go a little bit to the right of where I think the vertex is. And then I try to go where I think the vertex is. I don't know. That's close enough. And it'll tell me, it'll guess. So at 25, it's 31 and a quarter. Okay. So at 25. So I'm going to literally just enter in 25, and it says 31 and a quarter. So the first one was an approximation. And if you look at the table of values, it occurs between 20 and 30. So 25 is smack dab in the middle. That basically affirmed my thought process. So I'm going to take a screenshot of that, and we'll post that here. So that's T of X. Why do I have that little line there? That's interesting. Huh. I got a little line there. So let me redo that real quick and take the screenshot again. Oh, I see why. Hmm, peculiar. So that's the maximum height of that. Now, if we look at this, and I can clearly see that 36 is the maximum height on this one. And it occurs right in the middle of the symmetry, right? This number is the same as this number. This number is the same as this number. This number is in the middle of 20 and 40. So this maximum height is 36. So to find the answer, I'm just gonna say uh, the difference in the maximum height is 36 minus 31.25. Okay. So what is that? 4.75, I think. I don't know. Let me do it on the calculator and we'll double check and make sure. So if I say 36 minus 31.25, what do we get? 4.75? Yeah, 4.75. So the difference is 4.75. Let me double check the answer. I don't know if they rounded up to 5 feet or not. And then the second question is the difference in the total distance traveled is, let's see here. This one goes from 0 to 50. So now we're looking at the zeros, right? This is the total distance that they traveled. This is where it launches, and this is where it lands. So this one goes from 0 to 0. This one does 60 feet. So to find the total distance, I'm going to say 60 minus the 50. All right. So for this to go from 0 to 0, it traveled from 0 to 60 feet. So that's where this one comes from. This one went from 0 to 50. Oops. To 50, where it comes back down on the ground. So this is the height, right? So the thing goes up and comes back down, but it does it from 0 to 50 on this one. This one goes up and comes down, but it's 0 to 60. And the height is 0. The height is 0. Okay. So, anyways, that's 10. So 4.75 and then 10. And that's it.